So we need to find the power series representation, the radius of convergence, and the interval of convergence for the given series. So we will use the power series formula f of x equals ln of 1 minus x to the power of n, and it equals negative sum from k equals 1 to infinity of x to the power of nk over k, where x lies between negative n and n. So let's consider f of x, which equals ln of the root of 4 minus x squared. We can rewrite it as ln of 4 minus x squared to the power of 1 over 2. We will use the power rule of logarithmic, and we get that this equals 1 over 2 times ln of 4 minus x squared. Now we will divide on the multiple and divide 4 on the logarithmic function, and we get that this equals 1 over 2 ln of 4 multiplied by 4 minus x squared over 4. This equals 1 over 2 times ln of 4 multiplied by 1 minus x squared over 4. Now we use the product rule of logarithmic, and we get that this equals 1 over 2 times ln of 4 plus ln of 1 minus x squared over 4. Then this equals ln of 4 to the power of 1 over 2 and plus ln of 1 minus x squared over 4. And this equals ln of 2 plus ln of 1 minus x squared over 4. Well, now in order to find ln of 1 minus x squared over 4, we will use this formula here. Instead of x, we use x over 2, and instead of n, we have 2. So we get that this equals ln of 2 minus the sum from k equals 1 to infinity of x squared over 4 to the power of k over k. We can rewrite it as ln of 2 minus sum from k equals 1 to infinity of x to the power of 2k over 4 to the power of k, and this whole thing is divided by k. And in this case, x lies between a negative 2 and 2, including the endpoints. So now we use the ratio test to check if the series converges or diverges. To do the ratio test, we look at the case term of this series, which is x to the power of 2k over 4 to the power of k times k. And a k plus 1 equals x to the power of 2k plus 2 over 4 to the power of k plus 1 times k plus 1. Then L, which equals limit of the absolute value of a k plus 1 over a k, where k approaches infinity, equals the limit of the absolute value of x to the power of 2k plus 2 over 4 to the power of k plus 1 times k plus 1 divided by x to the power of 2k over 4 to the power of k times k, and k approaches infinity. Then this equals, let's simplify it, so it equals the limit of the absolute value of x squared over 4 multiplied by the absolute value of k over k plus 1, where k approaches infinity. Then this equals the absolute value of x squared over 4 times the limit of the absolute value of k over k times 1 plus 1 over k, where k approaches infinity, then this equals the absolute value of x squared over 4 times the limit of 1 over 1 plus 1 over k, where k approaches infinity, and this equals the absolute value of x squared over 4. So in order for this series to converge, this needs to be less than 1. So we get that x squared over 4 is less than 1 but greater than negative 1. So let's multiply all sides by 4. We get that negative 4 is less than x squared, which is less than 4. So that means that x lies between negative 2